Hello, everyone, and welcome to Groovy Duke, your channel for all things groovy-lang. If you find any of these videos useful, don't forget to like, comment, subscribe, and share so that more people can have a groovy day. So today we're going to be talking about groovy. Why groovy? So that's what we're here to talk about. Let's jump into it. And let's see, get my E off there. So who am I? I'm Tucker Pelletier, Groovy Duke pretty much everywhere, LinkedIn profile. Um, and I have this other link here, which is linked to, I put together, what I consider to be engineering standards and practices, best practices. It's a work in progress, but in there is also a lot of groovy resources, and I'm going to be tying that into the videos that I'm making here. So, so what is Groovy? Groovy is an optionally typed general purpose programming language with a lot of notable features in it. So it runs on the JVM, so it has seamless interop with Java and pretty much any other JVM language as long as there's a decent API to interact with it. It is optionally typed, as I mentioned. So, but you have the option of also doing static compilation to give yourself more performance and also get compile time errors rather than runtime errors, which a lot of people prefer. So it's always a back and forth. It's like dynamic good or is statically compiled the best way to go. You can have endless debates where which one is better, and look at the web. The web is dynamic for in a lot of cases, and it's web scale. So you know, it's one of those things where it's kind of like tabs versus spaces. You can say both are have their merits. So, but it is strong type under the hood. So an integer is an integer. You can't just take like an integer and put a string into it. That won't work without like conversion. But there are conversions within the language and whatnot, like there are in Java. It's a lot less verbose than Java. Now this has been changing over time because Java has finally kind of started waking up and adding a lot more features and evolving quicker than it has been in the past. But there's still a lot of features that are in Groovy that are not in Java. And you don't have to deal with semicolons at the ends of line, which is kind of nice. But there's also beyond that, there's a lot of other features. And through these videos that I'm going to be doing, I will go into a lot of those features so you can see what you're getting out of this. There are many tools that provide DSLs for simplifying problems. Some notable ones are Spock, Jeb, Gradle, Grails, and Micronaut. So I'll talk a little bit more about those in another slide. Uh, Another thing that Groovy did was, since it came out, after Java and is, I think it was 2003 maybe or 2005 when it came out. I don't remember offhand. I wasn't programming in it at the time, but anyways, what it did though was it mercilessly just stole like other feature ideas from other languages, open source languages, which is what makes open source great. So it has like a lot of ideas that came from Ruby. Without having Ruby syntax, things like meta programming, which I'll mention in a little while, some things from Python like triple quoted strings and string interpolation, inline lists and maps, like which are similar to maybe say JavaScript. So it took a lot of those and compiled it within itself, which just makes it a much nicer and richer language in my opinion. So I also mentioned that it has metaprogramming. It actually has two types. It has compile time metaprogramming via AST transforms, and it has APIs for that, so that you can actually modify code at compile time by modifying its abstract syntax tree using abstract syntax tree transforms. A little bit of a mouthful, but uh, but it's a very powerful thing, and usually used with annotations. I do have some a video. I will have a video on that and show you like some of the annotations that you have that Groovy just has made out of the box for you. So these are some things that you don't necessarily have to create yourself. They're more for framework and language designers, but they are there, and if you want to dive into it, you can, and they can be extremely powerful. So I will go over those. Runtime metaprogramming, so which is lends itself to creating DSLs. So I mentioned those other DSLs or other frameworks that had DSLs in them that save you time and whatnot. A lot of those are created through runtime metaprogramming and a mix of more compile time metaprogramming. That the compile time metaprogramming came after the runtime metaprogramming, so a lot of those features have been like merged in later. So, but you still have runtime metaprogramming. So, but as long as you're not statically compiling. Um, there are also some functional-like aspects with closures. Just think of those as like more powerful lambdas with the ability to mess with the delegate of the closure. So its scope you can actually set it at runtime as long as you're not doing static compilation. But I think there's actually an annotation that allows you to give it a hint so that you can set a delegate and have it statically compiled as well. Um, let's see. There are traits, which think of those as default methods on oh interfaces, but way more powerful because you can have variables, persistence, and stuff like that. Whereas with default methods, it's like all right, you can just have static methods. You can go a lot further than that with traits. There's this library called GPARs or Jeepers, depending on if you want to use the pun. Which I know one of the people in our community loves puns, but what it is for concurrency. So think of things like message passing. I can't think of the other. There's like several different types of concurrency tasks and I can't think of what the other ones are offhand, but there's different ways of handling concurrency, and this has a bunch of those just built in there so that you can use those in your program if you so need that. You also have an enhanced JDK. So Groovy has this thing called extension methods, and by default, it adds a bunch of them. And think of it just as, you know, a lot of things. It's like, shouldn't someone have thought of this and put it in the language? Well, Groovy actually did, and that's what you get with the enhanced JDK. It also has a bunch of enhancements for scripting, so that instead of writing out a whole public static main thing and doing system.out.println, you could just do println and it will actually generate all the rest of it for you. So that's why one reason you'll see Groovy used heavily for scripting. I know in some DevOpsy things and within Jenkins, Groovy is one of the languages that is used for that because it lends itself to that. But I wouldn't say that Groovy is just a scripting language because you can build, web applications. You can build it, anything that you can build with Micronaut, which includes, backend CLI programs, microservices. It is a general purpose language, so you can build pretty much anything with it. So moving on, frameworks. So I mentioned these before. So these are some of the big ones. Micronaut, which is a micro framework, which is very nice. It's very performant, has a low memory footprint, starts up very fast, and it was made for writing microservices and interacting with the cloud. So it has a lot of features, built in, just out of the box for things like integrating with Amazon, Azure, or Google Cloud, or stuff like that. Um, there's also Gradle, which is a build system, which I'd say the top two most popular build systems would be Maven and Gradle. I think Gradle should overtake Maven just because it's a lot easier. The reason probably it hasn't is more to do with like big enterprises and wanting to lock things down, and Gradle is a little bit more permissive with stuff like that. So but Gradle is it's a very nice DSL. It's a lot easier to read than Maven, debug and extend. So it gives you a lot of power, which is one of the hallmarks of just the Groovy language. Is it gives you a lot of power. It treats you like an adult. So kind of like think Python, but for the JVM. So it will give you all the rope you want to hang yourself if you so choose. But I will argue that you can write bad code in any language. Moving on, Spock. Spock is a testing framework. So think JUnit, but with the with tests that actually read more like you know user acceptance tests. So they'll have a given, when, then type of format, and it makes it so that it's a little less verbose than say JUnit, but has the ability to test just as JUnit you'd use JUnit to, and stuff like that. It also has a bunch of stuff for mocking and those types of things. Grails, which actually predates Micronaut, it's kind of like where Micronaut came out of. The same people who built Grails built Micronaut. Grails is a web framework for more building monoliths rather than microservices. Not that you can't build microservices with Grails, but it has a higher memory footprint and takes longer to start up, especially as the application grows. It's based off of Spring Boot. Um, One thing I will mention is a couple times through its history, it has had funding issues where it's gone from one company to another, and it's kind of going through one of those transitions right now. And I do know that there are people in the community rallying behind it, trying to see what they can do to keep things going. It may just become community supported, or maybe they'll find another source of funding. But unlike Grails, Micronaut has a lot more companies behind it because Grails is Groovy exclusive, whereas Micronaut, one of the things they did, which was a little smart, was they made it so that you could use straight Java or Kotlin with it, so it opens it to a broader community. I personally would use Groovy with it because I think it's a better than those two languages, especially for my productivity. But if you're really into Kotlin, you can use Kotlin, or if it's you wanted to use Java, you could use that with Micronaut. So it has since it appeals to that greater community, there's a lot more people behind it, and funding behind it through various companies. So, going to talk a little bit more about the JDK extensions. So, what I have here, this is, I'm not going to go through all of these, but there's, these are some of the, most commonly used classes that you'll probably use in the JDK. So you have string, collection, list, map. Those, you will be using those if you're using Java. Not to say that you won't be using others, but those you'll be using a lot more than I would say any other class, just because these are very heavily used. Obviously, lists and maps are interfaces, so you'll be using the implementations of those underneath. But this gives you like all of the APIs of those, so that you can compare them with the GDK, which is where all the extensions are. So I have just the GDK here, and then string collection list map. So I'm gonna switch tabs up here, and if you go to string, what you'll see is this adds a whole bunch of just methods that you can use, like decode hex or decode base 64. Let's see, take, so you can take characters within a string, or like you can take the number of characters from a string. um there's, oh wait, what was it, execute, which is one where you can take a string and just tell it to execute, and basically it gives you a process back. So instead of setting up a whole process to execute, say like an ls command or something like that, or a terminal command, you could do .execute. This makes string very powerful, and this makes Groovy very powerful in this sense. But however, if you do stuff, say with DSLs and stuff like that, there are ways to curtail this so that you can't just do a .execute on any string and have it run a command. So there are compilation customizers stuff when you do DSLs to provide you some security. So very powerful feature, and can be used in scripting or whatnot, but just something to be aware of. In collections, just a string, there's a whole bunch of extra methods here, like grep. Let's see. Where's one that the one I want to look at? Each. So each is kind of like Groovy methods for. Like, you can still use normal for loops, and for some cases normal for loops are better because you can break out of them. But with .each, you can actually pass it a closure, which is essentially just an anonymous function, your lambdas, and you can have it iterate over that collection and execute that code from that closure. So it's one of those things that's very useful. There's also a collect somewhere in here. It should be each collection. Oh, it might be on, not on collection, but it might be on one of the other ones like list, but which is similar to each, but allows you to actually accumulate a list of things that you are iterating over. So it's a very powerful feature. I will go over that in much more detail in some of the other ones once I get beyond this intro video. So, what is Groovy bad at? One of the things that I've noticed with Groovy is people use Groovy just to get stuff done, and they don't talk about it much. So, what's Groovy bad at? Marketing. Um, it's a very powerful and very flexible language, and I love it. But and it has a great community, but the community doesn't brag about it enough. And that's kind of one of the reasons why I'm starting to do these videos now, because it's like I've wanted to do this for a while. Um, and one of the things that the Groovy community will say is that Groovy wasn't meant to replace Java, but I'm going to say Groovy can absolutely replace Java, and you can use it instead of Java. Now, you wouldn't want to just get rid of Java, obviously, because you have all the libraries that you can use behind it. But it is its own language, and it can do just so much more than Java. It's like Java with batteries included and on steroids. So I think, obviously, I am a bit of a fanboy, and I think it's one of the best languages that I've been able to play with, and I've been playing with it for 13 years now. I always look at other languages, and I look at them from the perspective of, like, what am I losing by going to this language? And not to say that I don't use other languages or have to interact with them, because in various jobs that I've had to use other languages. Like more recently, I've had to use Go. Not a fan of Go, but that's a personal thing. And for the type of development I do, which is more web application development, Go just seems like overkill to me. It seems like all right, this is something that Google made to do networking stuff and things of that nature. To do Docker. So I prefer Groovy, and that's my this is part of my marketing pitch, so to speak. So, to wrap up, why use Groovy? It is powerful. You get a lot of productivity, flexibility, expressiveness, and conciseness. You'll see this more once I start doing videos per example. Um, it gets rid of a lot of the verbosity that Java is just known for being very verbose. Although in recent years it has become a little less verbose, which is nice. But Groovy takes it a bit further than that. You get frameworks that save you time. Less reinventing the wheel with the extensions. You get traits which are very powerful. Meta programming, which is just a whole new world of things that you can do and powers that you can have and wield. Um, you have DSLs which come with some of those frameworks that make some of your some of the tasks that you would do a lot easier. And then it just has all that compatibility and flexibility, so you can use any JVM library, and it just works. You can so all right, and hey, if you don't want to take my word for it, there's this guy called Paul King, and I think in this particular presentation, Soren joined him on that. Two people from the community. Basically, I've always been told if Paul King says it, it's true. He's pretty much the biggest committer to Groovy and has done a lot for the Groovy community over the years. So he is definitely someone to pay attention to. And basically, if you chop up off the Groovy today, you can see all of Paul's slides from various talks that he's given, and he gives very good talks. There's also the Groovy documentation, which is very good. They have a single page documentation, which has everything laid out there for you. I would say you don't need to know all of you don't need to get to know all of it and all of its features at the start, like things like actually creating ASTs and doing meta programming. You can save those for later. You can start, with simple stuff, which I'll go through in some of the tutorials, and then, build up over time and realize that, if you use some of the frameworks, you're actually already using some of the meta program stuff because of how things are implemented underneath. So, as far as videos, here's a whole list of videos. I'm not going to list all these out because this video is pretty much long enough. But I'm going to be doing a bunch of Groovy videos, and then there will be more to come on things like Micronaut, debugging, testing, Gradle, and worst practices, which is the funnest one. All right. Well, that's all I have for you today. So until next time, have a groovy one.